uh, here, he's going to speak on the determination of a model of demand, the case of the airport of Badajoz. I continue with the same thing I was telling you before. I think the tools that we have are wonderful. Wonderful tools for this. I'm going to tell you about a study that we have done in the airport of Badajoz. The airport of Badajoz is very small and has 4 flights per day, and not every day. And clearly they go to Barcelona and Madrid. And in fact, one of the questions is this airport really useful for the citizens of Extremadura, because the cost is very high. So then we have to see which citizens can be affected. This airport has an advantage, which is that it uses military facilities, which is the basis of Talavera de la Reina. The controllers are military controllers, which give a civil use for this type, and the cost is not so high, and also the trucks are being used for the combat aircrafts, and many people use the term of spatial interaction. All the analysis of flows, both for people and goods on the territory, use these terms of spatial interaction. That was also mentioned by my predecessor in his study about the public systems, the public transport systems. The interaction of those flows is directly affected by or has a direct impact due to the space, the distance of separation between the origin and destination of the trip, the separation of individuals, and the usability of the service offered increases along the time of the trip in order to have that service. Having information was costly, and it is still costly, because making questionnaires is more and more difficult. My wife sometimes gets angry at me when I am answering questionnaires through the phone. But it's very important, because if not, that would be impossible for us, the researchers, to have data. That had a cost, but there were also other costs, which are calculation costs, and that's quite complex. We'll see, which is the adjustment that was also mentioned by the first person in intervening. We adjust this minimum square adjustment or fitting. So this what it's done is whether this is used or not, knowing whether a person that is 90 kilometers from the airport is going to use it, or whether it's going to use it through this. So this is the decay distance. That's mainly the issue. Knowing the usefulness of this service within the spatial distribution for citizens. There are two terms which are closely linked to the decay distance, which is the resistance to transit, the cost of the trip, and the distance that I have on the land. That was also used in the analysis of land uses. The gravity models mean something very similar to what we understand as accessibility steward and many others. They are based on the gravity law of Newton, where they established that the relationship is going to be higher the closer you are from this origin and this destination, and will be lower the farthest you are from them, and the spatial interaction will be higher the higher are the parameters that we are assessing regarding the origins and destinations. Well, that was the thing. But there is a series of authors that establish that it is very convenient not to be based in this model, but go to other models, mathematical models, which are based on questionnaires where we obtain the revealed preferences of the users as a support that we can check. We can check the result of that research, the influence of the distance in the potential use of the service, sometimes contextualized through mathematical functions. First of all, we are going to see a regression curve, and then a fitting, which is called a tunnel fitting, due to the person that invented it. Then we have the Badajoz Airport. This is a very, very, very small airport, and we want to see how this is working through a questionnaire that was passed to the users of the airport in order to establish the decay distance of such a service.
And we try to adjust it, including regression curves, but that can be done with any spreadsheet really automatically. So their implementation will be very simple. First of all, we took WPS and the ortho photograph from the cadastre. We located the airport, and that became our starting point. We also had a network for all of the roads and the topology of the whole road network of Extremadura, plus all the towns and villages in the region. So with those three layers supported by the ortho photograph layer, we were able to start working and generating our own topology, which is a lot more simpler because we only have roads, one mode, and I'm only concerned with lines intersecting each other where they should, with junctions where there should be. Then I would have to set the impedance. In our case, is the specific velocity or speed of each individual road, taking into account their length, and so I can work out the time needed to travel all stretches. And then with that you can draw other elements such as the origin, the destination. In fact, we didn't have to calculate other costs. This is a matrix with the origin and the destination, and the time you take in minutes and the distance in meters. The system, loses its references. We had to use something to keep the references in connection with the councils and the towns in Extremadura, to calculate both time and distance and the cost it involves on the territory. Now, the matrix for the questionnaire, for the survey, which also analyzed some characteristics of travelers to be able to obtain more information, etc. But we were interested in the origin and the destination. We asked them, from which town did you come to the airport, and what town are you going to when you arrive at the airport? With that information, we could determine the inward and outward journey within Strémadura. And so we come to the next matrix. For each range of time, we have the population within that time distance. You can see all the time bands. 20 to 25 minutes, 50,000 odd people in Badajoz. And at the same time, from the survey, for that time band, we could draw the number of journeys from those towns. As you can see, in less than 10 minutes, there are 14 trips. Between 20 and 10, 310. So that allowed me to establish a ratio, depending on the population. In many studies, in fact, these rates are adapted to potential users based on the socio-professional profile who could be potential users of the airport service. The goal here was to see that fitting. This is the first fitting, taking into account the easiest method, a regression line, which only requires, to be able to use a spreadsheet, that's all. And obviously I've included a few more details, the formula, and then you derive the parameters that can vary in the formula to do a better fitting. N for the slope. So I do the partial derivate and then I sum it up. That allows me to draw the value of n. There's a mistake here. Sorry, I was in a rush this morning. Let me tell you something. As you can see, we have 7 levels. It's not a lot. We have the values for n and b, and so we can have a line with our values. The square figure is 0.47. It's not 1/506. That's wrong. I hadn't done the division, but this is the actual figure, or should be. The next functionality or function is the linear function. In this case, y equals e square to the power of beta x, where values are asymptotic to the abscissa axis. However, the first values show big differences, which increases the medioquadratic error, which is almost double here, versus the regression line. So this one wouldn't be useful. Now, y equals x to the power of beta. In this case, the medioquadratic error is even higher, and so the fitting is not right. But as in the previous case, values, when they are close to abscissa axis, the performance is okay. And this is the model we selected, which is based on Turner's model. This model gives us a good fit for all parameters. The average quadratic error in this case is reasonably acceptable, 0.28, and so we believe the system to be quite good in predicting populational potentials of the population who could access the network and use the service. And finally, the first model, sorry for the mistake, is 0.47, and then half of it for Turner's model. This is very important, particularly to identify commercial areas, business areas, which is very interesting, particularly concerning urban accessibility. Some studies have studied access by transport, by public transport. I remember some studies by the University of Madrid, by Gutiérrez Puebla and García Palomares. They have very, very interesting papers about the use of public transport. The latest one is about the underground. That's all from me. Thank you. I hope you're not too bored after this. Thank you, José Antonio. Thank you.